Hello everyone, welcome to my channel. So today we are going to learn about very important topic of SAT Maths because we were doing algebra in the SAT 1 and SAT 2 class. But in algebra as well there would be some like equations like slope of a line, different type of equations would be there. For that you should have some knowledge about coordinate geometry, that is also called analytic geometry as well. So let's move ahead with the definition of coordinate geometry, that is also called analytic geometry. So analytic geometry is a branch of mathematics that use algebraic equation to represent and solve geometric problems. It connects geometry and algebra by describing shapes, lines, circles, parabolas using coordinates on the Cartesian plane. So basically there is a minor difference, I can say. Coordinate geometry In coordinate geometry, we are going to be introduced with the xy coordinates, xy plane, how you are going to plot points, okay, distance formula, midpoint formula, external internal division. That are the basic concepts, okay, where points are represented with the xy coordinates. And analytical geometry is the application part. Application part means here we are going to represent different geometric shapes. For example, a circle, a parabola, hyperbola, even a line segment with some sort of equations. Like if we are going to represent a line in coordinate geometry, that would be represented like this, a line segment. But here in analytic geometry, that would be represented by algebraic equation like ax plus by plus c equal to 0 or y is equal to mx. Here in coordinate geometry, circle is a circle only, but in analytic geometry, the application part would be there. We have to represent it into a algebraic equation like x square plus y square is equal to r square. So from moving here to here, you should be proficient with the coordinate geometry first. So that we are going to learn. And one thing you should also know that there are two types of geometry, that is 2D geometry and 3D geometry. 2D geometry, there are basically two planes only, xy, and 3D geometry there are three planes, x, y and z. But here we are going to deal with 2D only. And like here different type of shapes that would be represented. And in 2D geometry xy plane, for every positive plane we have negative plane as well. And when it is divided like this, these are called quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. And this is the image representing line segment. This is image that is representing parabola. This is a image that is representing circle. This is a point H and K. There's a difference of that represented a difference of origin from the like outer point. So these are the advanced topics, and this is included in coordinate geometry. This is included in analytical geometry. Basically both things are same, but there is a minor difference that we can differentiate. Now moving further with the quadrants. This is the first quadrant, this is the second quadrant, third quadrant, fourth quadrant. According to the coordinates, the pair of the coordinates signs that would be different. Here x is that is positive, y-axis, that is also positive. Here x is negative, y-axis, that is negative. Here x and y coordinate, for example, you have to plot 1 and 2. So x is basically called abscissa and y is called ordinate. So this is abscissa and this is ordinate. Abscissa is a horizontal difference from the origin. This is abscissa. This is a vertical difference from the origin, that is called this abscissa. Yeah, this is called ordinate. Just a minute. Both signs are positive and this is the location of the point. 1, 2. Here x-axis, that would be negative, y-axis, that would be positive. So location would be here for the point -1, 2. Here if we have to find -1, -2, location of the point, that would be this. If we have to find 1, -2, the location of the point would be here. So that you should have that knowledge, like what is ordinate, what is abscissa, and how you will plot the points. So you just have to remember it is moving from right to left to down to right. In the first quadrant, signs would be positive. Second quadrant, sign would be negative and positive. Third quadrant, both sign would be negative. Fourth quadrant, there would be positive and negative sign. Coordinates of point that I've already discussed, abscissa and ordinate, that are discussed. Abscissa is the x value in the point, distance of the point along the x-axis. Ordinate is the y point, it is the perpendicular distance of the point from the x-axis, like this, that I have already discussed. This is called ordinate, which is parallel to the y-axis. The coordinates of the point are useful to perform numerous operations for finding distance, midpoint, slope of a line, equation of a line. Now plot the point A to 3, in which quadrant it does lie. 2, 3. So 2, 3, that is 2 is positive, 3 is positive, that would lie here only. 2, 3. This is the point. Which quadrant it lies in the quadrant 1. This is the first question that we have solved. Now move to the next question. Plot B minus 4 to C1 minus 3, that we have to plot, and we have to also tell which axis is each closest to. This is an important question. -4 and 2, that would be here only, -4 and 2, -4 to B point, 1 and -3 here, 1 -3. So how we are going to tell like which axis is each closest to? So B -4 2. So when we are plotting this point -4 2, we are going to left 4 units. 4 units we are going to left. Up 2 units. Up 2 units. So it is 4 units away from the y-axis and it is 2 units away from the x-axis. So 4 units from the y-axis, 2 units from the x-axis. So basically it is closest to, it is closest to x-axis. Here 1 minus 3. 1 unit from the x-axis, 3 units from the y-axis. Sorry, 3 unit away from the horizontal x-axis. This is a 3 unit away from the horizontal x-axis and 1 unit away from the vertical y-axis. So it is closer to y-axis. So you just have to count the unit which have the more units. Okay, that is basically opposite that would be closest. So here minus 4, you are moving 4 units from the vertical y-axis and 2 units from the x-axis. So basically it is closest to x-axis. Here go right 1 unit and down 3 units. 3 units from the horizontal x-axis. It is getting a lot of units from the distance from the horizontal axis, but 1 unit from the vertical y-axis, so it would be closer to y-axis. So you just have to remember this thing, like how many units, okay, that it is taking from the horizontal x-axis and you can say y-axis, vertical y-axis. So now moving further to the next question, plot D0 minus 5. Which special property does it hold? So start at the region, x coordinate is 0. So do not move left, right. This is a 0. The y coordinate is minus 5 here. So move straight down 5 units along the vertical axis. So this is the point 0 minus 5. So what special property does this point have? The special property this point is that it lies on the y axis. So it is a y intercept. It is a y intercept and it does not belong to any quadrant. It does not belong to any quadrant. Okay. So one thing that you have to remember, that about the quadrants, that is if a point is 0, 2. Okay. So what would be the intercept? That is y-intercept, because we have only value of y. If there is a point 2, 0, that would be x-intercept, because we have the value of x on. So this is a y. This thing is called here to here, region to here distance. That is called y-intercept. So what special property does this point have? It lies on the y-axis. It is a y-intercept. It doesn't belong to any quadrant. Plot E11 and F45. Draw the line segment EF. So where is 11? Here it is. Where it is 45? Here it is. And this is a E point, this is a F point. And we have to draw the line segment here. Just a minute. This is a line segment E and F. We are going to plot here E11. Just a minute. This is a point E, that is 1 1, and this is a point F, that is 4 5. That is a line segment. Now moving further to the next question, distance formula. The distance between 2 points x1 y1 and x2 y2 is equal to the square root of the sum of the squares of the difference of x coordinates and difference of y coordinates of the two given points. The formula to find the distance between two given points is follows like this. So like we have solved the previous question here. 2 points E and F. Line segment 2 points E, that was 1 and 1, and second point, that is 4 and 5. This point is called x1 y1, this point is called x2 y2. We have to find the distance. How we are going to find the distance between this line segment? That is x2 minus x1 square plus y2 minus y1 square whole square. So x2, that is 4, x1, that is 1 square, plus y2, that is 5, minus 1 square, that is equal to 3 square plus 4 square, that is equal to 9 plus 16, that is equal to 25. 25 square, that would square root of 25, that would be equal to 5. So if you don't have that knowledge how you will find square root, you can just 25 is a square, that is equal to 5 multiply 5, so 5 square, and basically root is, what is the root? That is 1 by 2, and the answer would be 5. The square root of 25, that is 5. And you have to write units with the distance formula. How many units? So this is the formula that you have to use. So same like this, you have to solve these three questions. Find the distance between A2 3, B5 7. Calculate the difference between this, and what is the distance between this. So this is the first question is easy. And the third is also easy. We are going to solve the second question because it has a negative sign of the coordinates. So we are going to solve this question. X2 minus x1 plus y2 minus y1 square. X2, that is equal to 0 minus 4 square plus minus 3 plus 4 square. So that would be equal to 4 square plus 1 square, that is equal to 6. Minus minus, that is plus. Plus 4 minus 3, that would be plus 4 minus 3, that would be 1. 16 plus 1, that would be root 17 units. Now moving further, midpoint formula. The formula to find the midpoint of the line joining of the point x1 and y1, like if you have some line segment and you have to find the midpoint which divides into the same ratio, like C, you have to find what is the formula. If this is x1 y1, this is x2 y2, and this is x and y, formula would be x1 plus x2, y1 plus y2 upon 2. For example, if you have 1.2 and 4 and second point 3 and 6, and you have to find the midpoint. So midpoint, this is a line segment, you have to find the midpoint. This is x1 and y1, this is x2 and y2. Midpoint you have to find, that is, for example, P, this is A, this is B. So P point xy, that is equal to x1, that is 2 plus x2. 2 plus 3 by 2, y 4 plus 6 by 2. 5 by 2, 10 by 2. So that answer would be 5 by 2 and 5. Here units you don't have to write because you are finding a point, not a distance. In distance we are using units. Find the midpoint of the line segment joining this. Determine the midpoint between this. What is the midpoint between this? So this is the first, second and third question, same as it is that I have done. We are going to solve the second question because this is with a negative sign. So the formula is x1 plus x2 by 2, y1 plus y2 by 2. Second question that we are solving. x1 minus 1 plus 0 by 2, y1 2 minus 6 by 2, because 2 plus minus 6 and plus minus minus. Plus plus is equal to plus, plus minus is equal to minus, minus plus is equal to minus, minus minus is equal to plus, if signs are there. So minus 4 by 2 and 2 minus 6. If you have 2 minus 6, what is the largest number? 6. So the sign, this is plus and minus. So the sign that would be negative. We are taking the sign of the highest number. Plus minus minus, but sign of the highest number, that is minus 4 by 2. And this is also minus 4 by 2. That would be minus 2 and minus 2. Answer. Now moving further to the next thing, that is internal and external division. So the section formula helps find the coordinates to the point that divides a line segment joining two points in a given ratio. Midpoint, if there is a midpoint, that will divide in the same ratio. But for example, if there is a point that is not divide the line segment in the same ratio, but it is dividing into like 2:1, like this 2:1, there is a distance of 2 and there is a distance of 1. That is a point that is not into the mid, that is not a midpoint, not a midpoint, and internally it is dividing the line segment. So how we are going to find that point if that is not a midpoint? There are two type of divisions, internal division and external division. Internal division, point would divide in the like you can say in the line segment internally. External division, point would divide outside the line segment. If we are going to increase that line segment and one point is there that is dividing that line segment, that is called external division. For example, I can give you one example here. Just a minute. For example, if some line segment is like this on a graph, and there would be some point, if we are going to increase that line segment and that point is dividing outside the line segment, that is called external division. We have two type of formula for internal and external division that we are going to learn. The point which is not a midpoint but dividing the line segment in some particular ratio, So external division and internal division, firstly we are going to learn external division formula. You will be getting ratio here. For example, if you have point 1 and 2, and then you have point 3 and 4, you have ratio like 2 is to 1. Okay, you have to find this point pxy. That would be, this is m, this is n. M that is equal to 2, x2 that is equal to 3, minus n that is equal to 1, x1 that is equal to 1 upon m minus 1. The first point P coordinate, that is this. Next, m2, y2 is equal to 4, minus n1, y1 is equal to 2 upon 2. So the answer would be 6 minus 1 by 1, that is equal to 5. 8 minus 2 by 2, that is equal to 3. So that external division formula 5, 3 is there. For the internal division, there is also a formula for the internal division that we are going to do. External division, that you have to remember the formula, that is m by mx2 minus mx1 upon m minus n, and m by 2 this is a formula, m by 2 minus n by 1 m minus n. Here for the internal division, the formula is equal to pxy, that would be equal to mx2 plus nx1 upon m plus n, m by 2 plus n by 1 upon m plus n. So we have to find here a 4 7 and b x minus 3, and the ratio is 1 2, and find the value of x. So this is little bit advanced question. Find the value of x. So we are going to solve the question as it is. Point you have already given, that is equal to p point, that is already given, that is equal to 2 3. And m that is equal to 1, x2 that is equal to x, plus n that is equal to 2, x1 that is equal to 4, m plus 1, 4 plus 7. M that is equal to 1, ratio is 1, by 2 is equal to minus 3, plus n 7, 4 plus 7. So 2 3 is equal to x plus 8 by 11 minus 3 plus 14 by 11. So 2 3 is equal to x plus 8 by 11 and 11 by 11. So basically 2 3 point is equal to x plus 8 by 11 and 1. We have to find the coordinate. We have to find the coordinate of, we have to find the value of x. So 2 3 is equal to x plus 8 by 11 is equal to 1. So if a b is equal to x y, then a is basically equal to b, x is equal to y. So here 2 is equal to x plus 8 by 11. We are going to do cross multiplication. 22 x plus 8, 22 minus 8 is equal to x, that is equal to 14. X value, that would be 14. So these type of questions can also be there in your SAT exam, where they are going to give you some advanced question related to midpoint formula or internal or external division. So you just have to remember the internal division formula, that is basically xy is equal to mx2 plus nx1 upon m plus n is equal to my2 plus ny1 upon m plus n, and external division, that is equal to xy is equal to my2 minus ny1 upon m minus n, my2 minus ny1 upon m minus n. So if they are giving you some sort of ratio and some sort of points, and you have to find x or y coordinate, then you are going to solve like this. This was the question here. Find the if P23 divides the line joining A47 B x minus 3 internally in the ratio 1 to, find the value of x. Internal division, we have this formula. This is x1 point, y1 point, x2 point, y2 point. Ratio is m into n ratio. You have to put the points, solve it, and you are going to find the answer. So the midpoint of the line joining is m. Find the coordinates of m using the section formula. So what does it mean? They are giving you midpoints of the line joining. Okay. So we are going to solve this question here. Just a minute. Question is, midpoint of the line joining is A5 minus 3 and B minus 1 7. Midpoint of the line joining, that is M, that you have to find. And the coordinates. Coordinates are given A5 minus 3, B minus 1 7. A5 minus 3, B minus 1 7. And we have to use section formula. We have to use section formula. So now they have given you a hint. What is the hint over there? That is, you have to find the midpoint, and the midpoint always divide the line segment into the same ratio, like 1:1. So m would be also 1, n would be also 1. Section formula that you have to use, that is a midpoint, so that section formula you have to use internally division section formula. So mx2 plus nx1 upon m plus n, that would be the first coordinate. My2 plus ny1 upon m plus n, that would be the second coordinate. 1 multiply minus 1 plus 1 multiply 5 upon 1 plus 1. And the second is 1 multiply 7 plus 1 multiply minus 3 upon 1 plus 1. So the answer would be minus 1 plus 5 by 2 and 7 minus 3 by 2. 4 by 2 is equal to 2. 7 by 3, 2 by 4 by 2, that would be 2. So the midpoint is basically 2 and 2. So this point is 2 and 2. So midpoint of the line joining, that you have to find section formula that you have to use. You know that the midpoint that would divide into the same ratio. So you have the ratio m1 and n is equal to 1. Internally, because it's the midpoint, you have to follow the formula and solve it. Now find the coordinates of the point that divides the line joining internally, and the coordinates, find the point P, divide the line segment internally in the ratio. That is your homework that you have to solve it by yourself. Internally, externally, midpoint, how you would find the value of x, everything I have explained. This is your homework, and after doing this homework, you have to answer in the comment what is the answer of this 1 and 2 question. Now the next is external division question, that I have already given you the full explanation. That is also your homework. This is a question. P5 to divide externally in the ratio, a point divide externally in the ratio, externally in the ratio, and find the value of x. This is the same question that I have discussed. This is also the question that I have discussed, how you will find the value of x, how you will find externally in the ratio points, so that you have to solve it by yourself. And then the next thing is, thank you for watching my video. And before that, we are also going to learn the things that we have learned in our class today. First, we have learned what is coordinate geometry, what is basically a coordinate geometry, what is analytical geometry, 2D and 3D, what are 2D, 3D planes, quadrants, and line segments, how to plot line segments, as well as midpoint formula, distance formula, external and internal division, how to find the value of x, these points that we have covered. So this is the basic thing when we are going to move to the slope of a line, different type of equations. This is a basic thing, and here you are going to get at least 4 or 5 questions from the coordinate geometry. But we have to do slope of a line, so many questions in algebra as well. So that's why I have discussed in SAT 3 some things, basic things about the coordinate geometry. Thank you so much for watching, and do let me know if you have any doubt about the questions that I have discussed in the video, as well as whatever the homework that I have given you. You have to do that homework and answer those questions in the comment box. And please subscribe my channel. Thank you so much.